Hi there, Dan Sinclair with Teach for Mastery again. This time we're talking about the secret number 4, why math is hard. And I want to show you something that happens here in math that oftentimes gets overlooked. Oftentimes students start out learning to do math and they learn to count, because counting is the beginning instructional mode for mathematics. We learn how to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 0 is also important to throw in there. Now, in doing so, we teach students to go 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. And we teach students to do that counting pattern. However, as students progress into higher level math, especially even into just arithmetic, if students are trying to add 3 and 4 together, and the way they add 3 and 4 is to go 1, 2, 3, 4, 5, 6, 7, they're not doing addition, they're doing counting, because they don't have the ability to see 3 as being 3 and 4 as being 4. So one of the things that the masterpieces do is they get students to see numbers as whole values, which is so incredibly powerful as students progress into higher level mathematics. Let me show you what I mean. So we would use the green unit cube for 1 because that is the correct representation. But here for number 2, we would take our 2 unit cubes and we would replace that with an orange bar. Then we would replace the 3 green unit cubes for 3 and we would put a pink bar in. We could replace the 4 green unit cubes for 4 and put a yellow one in. And you should already be familiar with this one. This one would be the light blue 5. And then this, for 6, we actually have a nice purple color for 6. And I could go on, but I'm going to show you this. So this is the masterpieces. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All color-coded, all of them have the number written on the side, so students can see the number and the value together at the same time. Building that understanding, able to understand how the number is a whole value as one thing. And therefore, when they go to do addition, the number of 3 and the number 4 there, and I'm going to put the value of 3 and the value of 4 right here. Now, the one thing we need our students to understand is, what are we combining? Are we combining the numbers or are we combining the values? Well, let's see. Let's combine the numbers together. If we combine 3 and 4 together, we would get 34. I don't think that's right. Okay, so we can't combine the numbers together, which if you just tell students to combine 3 and 4 together, that's what they're going to think. But we need them to understand we're combining values. So now we're combining the value of 3 and the value of 4, and we're going to combine them together like this. So now I've made a longer length. Now, if you're going to teach kids how to do this, what we need to do is explain, why do we do this? Why do we combine 3 and 4 like that? Well, think about it in real life. What are big rectangles in real life that move and combine together just like this? They go click. Well, how about train cars? Boxcars on a train. The boxcars on a train are connected by a coupler, right? That coupler, if you think about it, looks like an addition sign, the plus sign. So whenever students see the addition sign, it means that they're going to combine the values on one side of the addition sign with the value on the other side of the addition sign. And once they do, they've now made a longer length. So now we need to know, what new length did we make? Well, in this case, we could put this bar up there, which is 7. The 7 bar is the same length as if we combined a 3 and a 4 together. Now in doing so, notice I left a little space in between. I didn't just slam them together like this, but I left a space. And the reason why is we're trying to explain the mathematical symbols that we use, the specific notations. So one of the symbols we use is the equal sign, which is 2 horizontal parallel lines. Do I have 2 horizontal parallel lines right there? Sure do. So now if I'm going to teach students, 3 when combined with 4 makes the equal sign, because what's on the other side is the value of 7. And when students understand this, we can go into all sorts of different types of equations. And understanding what an equation is, a math problem with an equal sign, gives students the ability to do all sorts of stuff. So I hope this will help you to be able to explain things to your students. I look forward to seeing you next time.